Hello. Today I wanted to make a video about what I consider my so far life's work, Coder's Basilisk, also known as sea bass. The original name was the name of the fish. I renamed it to sea bass, the letter C, B-A-S, later. I actually kind of regret the name change a little bit, but the Coder's Basilisk does better convey what it's all about. I have made videos about Coder's Basilisk before. I made a video that I put on my YouTube channel before, but today I wanted to talk a little bit about what the use of it is. Anyway, I just want to show you real quick that there are examples, little examples, right? This is Hello World, right? I made some example programs. This is a program which modifies C code into a giant string literal instead of a Coder's Basilisk header file. I just wanted to show you guys what this project is all about. So basically, the whole theme of Coder's Basilisk is that the compiler is able to be modified. Hold on, where is the Reflect? I think the base level library, right? So there's this library called Reflect, and basically what this does is it allows the user's code to actually access the compiler at compile time, right? You can do stuff to the compiler at compile time. This is actually, this system is used both to extend the compiler to add new features to it, and it's also used to generate code, right? So if I scroll through here, hold on, I can you see here you can directly access the parsed AST, right? And basically this sort of thing, right? I don't know of very many languages that have anything like this. The only language I know that's quite like that is Rust, right? And the big metaprogramming feature that this language has is it has something known as the parse hook. Any function which you declare codegen, that means this is part of the compiler. This function will be incorporated into the compiler for the duration of the compilation. It won't be permanently added. It's only for that compilation unit. This indicates that it's added to the compiler, and anything that starts with parsehook _, right? We can now call this function during parsing by doing @BLDR, and it can, and that allows you to access the the sequence of tokens and modify them during compilation, right? And this allows you to put in intermediate level compilers. This is all stuff to manipulate the token list, right? This is not really important. By the way, this is an object-oriented language. You might notice that this paradigm here, you can use a period here too, but basically this allows you to say that you're calling a method on an object. And this is another parse hook. And now we use the written parse hook to make a new parse hook, right? This parse hook here, what this does, by the way, what this thing does is it allows you to access a special namespace, which I believe I defined up here, right? Yeah, I defined it up here. This is a struct I defined. Anyway, and so when you're writing builders, right, I wanted a namespace specifically for parse hooks in builders. But anyway, that's not important. Point is, you can edit and modify the token stream during parsing time, and this basically allows you to intermediately stack compilers, right? And I went fairly far with this concept. Here you can see we do some pretty advanced metaprogramming here. Right? This is a recursive descent parser library. Right? All glory to the Lord Jesus Christ. Amen. And this is basically a domain-specific language for writing recursive descent parsers that operate at compile time on tokens in the token sequence, right? In the parser's main token sequence. And here's make builder. Anyway, you don't need to understand the syntax of any of this. You don't need to understand what any of this does. You just need to know that this is pushing the limits of what compilers are designed to do, and it makes them way more flexible and powerful. What Coder's Basilisk lets you do is it lets you piecewise and incrementally build new components onto an existing compiler. Now it gets better, right? Because if we go out here, you can see that there's actually a library here, which you might be able to see this, right? Actually, if we // we use the 2C library, and we have this function here called cogen_main. And what this function is responsible for doing is after the entire unit has been parsed, this function here is called by the compiler. As you can see, it's cogen, so it's part of the compiler, and we call this thing, right? This function here. This is the main function of the C code generator. So this compiler is self-retargeting. Okay, well, self is maybe a little bit pushing it. You do have to write your own code generators, but it's basically just a header file. This is a header file that turns your code into C code. I don't know of any compiler on Earth that does quite this, right? I suppose you could, if you were willing to write your own entire Rust compiler or whatever, you could replace Rust's backend, maybe, but it would be really hacky and shit. This is designed to do this, right? You are designed to be able to emit any language you want from Coder's Basilisk. So you could parse this, all right, get an AST, and then walk through all the symbols and emit anything you wanted, right? As an example, right, I actually wrote a code generator for a virtual machine I wrote. Where is? I wrote a 32-bit virtual machine, which has a 32-bit address space. All right, and we can compile Coder's Basilisk to TP-CPU. Right, it's a fairly long file. It's over 3,000 lines, but it's that's what you get when you try to generate assembly, right? Instead of C, right? I believe the C code generator is substantially shorter. Yeah, it's 1,000 lines shorter, about. Maybe slightly less than 1,000 lines. I don't remember. It's 1,000-ish lines shorter. And there's a bunch of these comments, right? I don't think that there's nearly as many of these comments in that other file. This was the first time I ever wrote a code generator for Coder's Basilisk. It was kind of a proof of concept at the time, but I do actually use it. Anyway, but my point is, so what Coder's Basilisk does for you is you are allowed to incrementally add onto a compiler at the front end, right? Adding new features, adding new language constructs. You can even add new semantic analysis. You can add optimization stuff to the compiler, whatever you want. You can add a new AST. You can have an entirely new language that exists right alongside the base level language, right? Anything you want, right? And then you can emit any language that you want using this compiler framework, right? And this is incredibly powerful. What this enables you to do is it enables people with relatively low skill to do compiler development, right? They can create new language features for programming languages, for this programming language, without having to write an entirely new language. They can just add itty bitty little bits. Like, as an example, where is it? I guess I can show that, right? As an example of a language feature I added templated code. Basically, the way that this works is, where is it? I think it's called CGSTL. Oh, we were about to open it. This is the compile time standard template library, right? I didn't write very many classes. I wrote vector, and I ended up having to write vector multiple times because I need it for structs, classes, and primitives. They all work a bit different. The difference between a struct and a class, there is no actual difference, but if a struct or class has a constructor and destructor, we need a different version of vector and stuff for it. And and then we have the main CGVec, right? And what this does is it tries to infer what the which one of these it should use. Should it use the primitive? Should it use the class? Should it use S? Right? And then we have unique pointer. But basically, this is I was able to add templates to the language, and the way that I was able to do this was using metaprogramming. This is the metaprogramming operator. This is a parse hook being called, and then after this, the parse hook takes over for parsing, and it'll parse all of the stuff inside these brackets. Now, I chose these square brackets as a convention. This is not a limitation of the parse hook system. The parse hook system can see all the code below it. It's just I chose to wrote these things so that they operated within this context. And that's important, by the way. If I didn't make it that way, then there would be complications with trying to implement new languages or utilities using Coder's Basilisk. It would mean that some syntaxes would be impossible, right? And I just want to show you another example of a tiny little language feature that I wrote. No, this isn't it. Where is it? Where is it? Mini abstractions. There we go. I implemented this system here, which is a new way to write operators, right? So basically, there's this thing where you want to say a equals 7, right? Or a equals 3 plus 5. I mean, this is equivalent, right, in my language, right? But it's 5 times 37, right? So you want to do something like this, right? I made this as an abbreviation of this, right? And that was the purpose of this this little thing here, right? And I did it for not equals and I did it for neck and, right? Anyway, I just wanted to show this, right? This is an example of a tiny little language feature that I was able to add, and it didn't take me very long to write this, right? I implemented one of them, and once that was working, then I was able to implement all the other ones, right? I do also have the string comparison version, right? If I'm comparing strings, strec is an operator in this language. It compares C strings. Anyway, but so basically, if you are someone who is a programmer and you have ideas about how you want to implement new language features, but you don't want to write an entirely new compiler, you don't want to design a new programming language, you want to work with existing programming languages, this is the tool to do it, right? This will allow you to write new language features into a compiler that's already able to work with basically everything, right? And I mean basically everything. We already have a backend for C, right? So you can write Coder's Basilisk, compile it to C, and then compile it with your C project. And there's no there's no real issues with that, right? We can even handle multiple compilation units and stuff like that, right? It's not an issue. Coder's Basilisk only operates on one compilation unit at a time, but in principle, there's not really any issue with working with multiple compilation units. You do have to be you have to make sure that the names are the same across compilation units. That's about it, right? So you need, if you're auto-generating names, you need to make sure that the auto-generated names are the same. But most of the time, you're not going to be doing things like that. But, so anyway, that's that, right? No other language really allows you to do this easily, to my knowledge, right? Rust does have a really powerful metaprogramming system, but in practice, I think that it is kind of a worse version of what Coder's Basilisk has. Where Coder's Basilisk's metaprogramming is far more robust and mixes with the code better. All right, hold on. There was something I wanted to show you. Is it in here? Yes, here it is. Here it is. This is a recursive descent. This is a domain-specific language I wrote. This is my printf replacement, right? You know, I wrote a printf replacement. This is my version of printf. I didn't make it like feature complete or anything. I didn't, for instance, write float to integer, or anything like that, or float to string. Pardon. I didn't make a float to string implementation here. I could. I have a float to string implementation. I should probably port it into this, but you know, it serves my purposes, right? This is a perfectly usable replacement for printf, right? So I found, and this is an example of me using a domain-specific language in my code base to implement something, right? And I realized that this is all of the syntax here is going to be very confusing to you because you're not familiar with it. But I just wanted to give this as an example of what's possible, right? This is the kind of work I did as a computer scientist. I'm not a very good programmer. I have good ideas, but I'm not very good at actually making them happen. Partially because I'm lazy, partially because, I don't know, I'm not like highly trained on how to make the most readable code or whatever. I just have ideas and then I make them happen. Point is, you know, this is a very flexible, powerful system which allows you to do things piecewise, right? The problem with being a compiler dev is that if you design a new programming language, no one wants to use it because it won't work with anything, right? Even if people like your language, even if it has cool features, it doesn't actually work with anything. So, you know, it's not compatible with anything. It doesn't have any libraries that it can use, right? Coder's Basilisk can use libraries, right? So let's go to the 2C thing, right? I personally ported all of OpenGL 1.1 into Coder's Basilisk, right? I went through every single function, right? And I'm using inline C here, right? So this is working with the 2C backend, right? You are able to use OpenGL 1.1 in my language, right? I also ported OpenAL 1.1, right? You know, so we have OpenAL. That one's a little bit more useful than OpenGL 1.1. I also, these things here, these are, I can show you. The point is that when we compile a compilation unit, we want to include this code here into the compilation unit. So I just have the code. I tell the code generator to shove this code into the compilation unit. Right. It's exactly the same as if I included it into the resulting C file. It's a little bit more convenient that way, and those are those, right? And I've also written libraries that use. Okay, hold on. I wrote the fun library. This is a little library I wrote for writing video games. Right, and as you can see, it uses my OpenGL port. I did actually use this code, by the way. I think I used this exact code. I think I used this exact function. And I use inline C here, right? So any C library, more or less. Maybe there's some that are somehow incompatible, but I think pretty much every C library you care about can probably be used with Coder's Basilisk. And if there's not a reason, I don't know what the reason would be, right? So, and you can compile the 32-bit or 16-bit or 64-bit, right? There's no 128-bit support. You could add it, right, to the compiler, but it would be you'd have to do quite a bit of work to add 128-bit support, right? But 64-bit support and 32-bit and 16-bit, you can do this, right? You could compile code for the Amiga, probably. You'd probably have to do some fiddling with the settings, but you could probably work, right? So this is already compatible with C, which, as you know, the whole world is built on C, right? The C programming language is the lingua franca of systems programming, the standard lingua franca of systems programming. So that it's not really a language, right? It's got a language in it, but then there's it's more like a compiler framework. My framework here is flexible enough and powerful enough that you should not be limited in what libraries you can work with or what you should be able to compile to. You can already use basically anything that you were already using if you were a C programmer, right? And by the way, this is public domain, right? So there's no intellectual property restrictions. I'm giving it to you. You can steal it, right? There's no issue about leaving attribution files in the repository with some guy's name in them, and you don't. It's not like the BSD, I think 3 clause, I forget, where like in all advertisements you have to say whoever the hell's library you used. None of that bullshit, right? Just steal the code. Just download it and use it, right? And I find that very important. What this all basically adds up to is that I've basically taken the practice of making new compilers, making new language features, making new programming language elements, and I've turned it into something that is completely free, easy, and incremental, right? You can do it piecewise. You can do it even if you don't really know the whole scope. You don't have to write an entire compiler, right? You just need to know how to write a little bit of parsing, right, or that kind of thing, right? You need a lot less expert knowledge than people in the past have typically needed in order to add new features to a programming language. Now, you might ask yourself, why is this valuable? Why is it valuable that people can write language features very easily, right? And why is this important? Well, the reason is that computers have been getting really, really fast, but our ability to utilize computers has not been keeping up. Software development has barely advanced at all since the 80s or 70s, right? C89, which had existed since the 70s, as I understand it, although not with every bit of the standard in it, right? It's just like, in general, the C language did exist since the late 70s, as I understand it. That language is still basically the bedrock of all programming today, right? And it's kind of stupid that it is that way, right? That programming languages don't keep up with the minds of programmers, and actually they sort of hinder them, because compilers should be doing more work for programmers. Compilers should be doing more of the thinking. They should be automating human thought. And not in the same way that like AI does. I mean like in the way that really advanced compiler optimizers do, right? That's an area that has advanced quite a bit. although I think it's still fairly retarded from where it should be. Software development is retarded. And I mean that not in the offensive sense. I mean that in the scientific sense. It is slowed down. It is slowed down from where it could be because compilers are stupid. Compilers have to work with a crappy language that doesn't really express everything that the programmer wants to express. The programmer has to waltz around in order to build the constructs that they want, right? They need to do weird, complicated things in order to express the ideas that they want to express. And so, oh, by the way, I should show you. This does have a manual built into it. Right, so you can read about the base level language if you want to, right? And I do need to update this a little bit, but you can go through it and read it, and most of it should be applicable still. If programmers get a hold of this, if this becomes mainstream technology and people are working with this and they're writing new language features and they're being put out into the open and people start experimenting and playing around, I believe that humanity will advance very, very quickly because software is a tool by which humans accelerate their intellectual work. People are able to do intellectual work faster when the software is really good. So if I make it really easy for people to make software, then software will get better faster, and intellectual work will be done faster, and the world will become a theoretically better place. That's the hope. As long as people use their brains to do good things, not bad things. So fewer nuclear weapons and more saving the whales, or whatever. Or figuring out how to grow more food in less land, or using less water. Right? Hold on, let me get my water so I can drink it. I need more water. Coder's Basilisk allows an individual person, right, who is creative, who is thoughtful, to write anything from a tiny little compiler tweak to an entirely new programming language with relatively little expert knowledge and relatively little effort. And as people continue to work on this technology, and people contribute new metaprogramming tools and metaprogramming utilities, I guess those are the same thing. Tools and utilities. Is there a difference? I think kind of, maybe. But you get the idea. As people make more metaprogramming tools and utilities, metaprogramming will become easier in and of itself, right? And that might sound very similar to you if you've heard about this stuff about AGI, right? People are talking about how AI will be able to research AI, right? And that's going to be like the singularity, right? And then we're going to get superhuman AI inside of a tiny little box, and it's going to be amazing. And that's kind of the idea behind all this AI hype that has been happening over the past few years. I'm not entirely sure that is going to happen. The thing is, I'm not sure that God will let it happen. I'm not sure that humanity will be allowed to create something smarter than itself. But using the human brain the best we can, I think, might get us really far. And that's what Coder's Basilisk is all about. Coder's Basilisk is all about using human brains the best we can to create software. Not computer brains, human brains. And the way that we do it is by using computer brains better so that human brains can be better concerned with higher level ideas. And it's not just higher level ideas, it's also like I've done substantial thinking and research into the nature of metaprogramming. My research has mostly been thought experiments and examples, but basically the metaprogramming really should be called the meta of programming. It's the question of how does the human get the computer to do exactly what he wants, right? How effectively can he do it? How quickly can he do it? And the more efficiently and effectively a human can get a computer to do what he wants, the better metaprogramming is happening, right? The better metaprogramming you have. And that is the ladder of advancement that Coder's Basilisk offers to you as a programmer. To the wider community of programmers. An individual person, right, is very limited in what they can do for themselves, right? You won't actually be able to come up with ideas fast enough just to personally become a superhuman programmer. Unless you spent literally all the time on it, maybe. I don't think that would happen, though. But when the community gets a hold of this, there's going to be so many amazing tools and utilities and stuff being written, and so much frontier research happening into compiler design and programming language design that will push the programming into the 21st century, to be honest, right? To be very frank, even the newest, shiniest programming languages out there pretty much are still stuck in the 20th century in most of their crap, right? Rust is mostly 20th century crap. There's tiny little bits of it that is truly invented in the 21st century. But again, to be frank, if programming language technology had been advancing properly, we would have gotten all that stuff, or better stuff, or whatever, in the 20th century. I believe, right? If we had proper metaprogramming tools, if we had the parse hook, right, the key insight I had with Coder's Basilisk was the parse hook. Right? CBAS-M parse hook. No. CBAS enables metaprogramming by allowing your code to hook into the parser. You are literally adding new code to the parser of the compiler. You can write a function and then use it to do parsing. It takes a fair chunk of code to set this up. Again, because I'm not an expert at making this super easy for you, but I have written utilities. Right, I wrote the builder utility to make writing parse hooks easier, and I even included a minimal complete example program. This probably still works. I'll have to go back and test it. Anyway, so I hope that if you are a computer science major, if you are a programmer, I hope that you appreciate this technology, right? The ability of being able to write code that literally adds to the compiler and is able to manipulate parsing. Because this more or less does not exist in most languages. Again, it does kind of exist in Rust, but it's really crap. We actually have it good here. We have it usable here. In Rust, it's a piece of shit. I'm sorry. Like, in order to do it like we do it here in Rust, you'd have to wrap things. You'd have to write your own Rust inside of Rust. It would be really crap. I have the boilerplate for top-tier metaprogramming right here, right now. And I'm making this video because I want to ask anyone who watches this video who is capable, who is competent, to study my work, study what I've written, study the code I created, and use it. If you find my implementation shitty, you can write a new one. But the important thing is that my ideas are not lost. And I actually believe that this particular implementation is good enough to begin the revolution. Okay, to begin the conquest of the true capabilities of the human mind and the computer by humanity. And it's completely free and without restriction. I spent many years working on this, studying this, in order to create it, in order to put it together. I don't want it to be lost. And I mean, I'm concerned about my future, right? I'm concerned about what's going to happen to me in the next 5 years. I could use the Lord Jesus is my only hope, right? I should have been a better Christian. I should have. But, back to the subject at hand. This technology is useful, it's powerful, it's already a capable programming language. This is already a pretty decent C replacement. It's missing some features. It's missing support for integers larger than 64-bit. You'll find that to be maybe kind of hard on you. If you are writing a lot of encryption code, or if you're working a whole lot with if you are working directly in inline assembly with what's it called? Vectorized operations, SIMD operations. If you're working a lot with SIMD operations directly, you might find that a little wanting. But for the most part, you can write inline C and just get around that, right? And you can make a struct that is 128 bits, right, and pass it into a function. Although, admittedly, we do not have support for passing structs by value into functions. That's another thing that's maybe a bad decision on my part. But ultimately, it's for most purposes. I've actually found that when I compile my code using Coder's Basilisk, if I write something in Coder's Basilisk and compile it to C, and then compile the C code, that typically tends to run faster than if I write it in C directly. I'm not entirely sure why that is, but it just happens to be that way. It's basically on par with C, right? There will be specific situations where C will outperform Coder's Basilisk code, but it's a very niche thing. And it's something that you can get around, and if you really have to, you can write the parts of it that have those features in C, and then mix it with Coder's Basilisk code. It's not an issue. So I think that you should start by studying this work of mine. You should also know, by the way, that I have done other work in metaprogramming. So I wrote TP-CPU. The idea behind this. This is a computer architecture that I designed. A full computer architecture I wrote. Is this how you run it? Yes. I wrote my own operating system on my own computer architecture, and it's And hold on, let me. And I wrote some utilities, right? I don't have a text editor yet, but I do have something that can hash files, right? I created this thing, and the reason I created it was to host programs in a portable way. The idea was that you could just reproduce the emulator, and then you wouldn't have to reproduce anything complicated. The emulator is very simple. But the real big thing about... no, that's the wrong folder. The real big thing here about... this thing is that while I was working on it, I invented a way to add metaprogramming to the assembly language. And I have realized that this method for adding metaprogramming, real metaprogramming, actually powerful metaprogramming to an assembly language can work for almost any assembly language, right? You can add real metaprogramming to almost any assembly language. Now I have thought this through, and at first I thought that this was the best thing ever, but I'm not entirely convinced anymore, because if you use Ironrod the way that I've written here, what you're going to have to do in order to do what Coder's Basilisk does is you're going to have to recreate Coder's Basilisk from the ground up from assembly language inside of the assembler, which is very doable, but it's very complicated. It may end up being superior to implement that way, because you can sort of piecewise implement it in such a way that it can be ported to new assembly languages very, very easily. Sort of like how operating systems have a hardware abstraction layer, and that hardware abstraction layer basically allows the operating system to pretend as if it runs on anything. And then the hardware abstraction layer says what the actual system specifics are, and then the OS just works with that. And so that's maybe why Ironrod is a better approach. It's as it says on screen, it's a primordial metaprogramming approach. Right? You are going completely from the bottom, from assembly language all the way to the highest levels of metaprogramming. That's the theory behind Ironrod. I never actually went anywhere and actually implemented any real metaprogramming stuff using this, but I know that it is possible in theory. I'm very, very confident that you can that a capable, thoughtful person who is familiar with metaprogramming can take Ironrod and work with it and flesh it out and make a sort of hardware abstraction layer version of Coder's Basilisk that lives on top of Ironrod assemblers. Right. And so that's some more work I've done in metaprogramming. And it's also public domain, by the way. It's CC0, just like Coder's Basilisk. And all of this was written by me. I do not believe an AI wrote even a single line of code in this. I haven't really used AI to write any code, except like examples. When I wanted an AI to write, I wanted an example of a triangle rasterizer. So I asked ChatGPT to generate me a triangle rasterizer in C for me to look at. That ran on the command line. But I didn't use any of that code in Coder's Basilisk or TPCPU, so it's all above bar, right? This is human code, and you can just use it, right? And if you're a rich person who has a lot of money, I wish that I could benefit from that lot of money. I could really use that. But I've accepted that my contribution to humanity is I'm not charging any money for it, so I'm probably not going to get very much for it, other than maybe the respect of some computer nerds. I feel like I don't get that very often. By the way, and if you want to get Coder's Basilisk, hold on, let me go to it's on Codeberg. If you go to Codeberg and you go to, this is the repository, codeberg.org/gec/coders_basilisk. Here's the URL. And this is the code, and I have a README here. I explain how to build it and test it. And I also talk about how to learn the language. I basically just say, check the examples and look at the tiny bit of documentation that exists. Yeah, I know that I should probably make proper tutorials. It's just I haven't gotten to it. Public domain. Can I yell any louder? Please steal my code. All right. I wrote this a long time ago. I was feeling like ass when I wrote this. You can ignore this. Anyway, so I wanted to make a video about this stuff that I wrote, this bunch of time I spent. I hope that someone steals my code. I hope that someone watches this video and realizes that this is valuable, that this is important, and that they need to steal it. And you do. This is important code. Thanks for watching, guys.